Welcome back, engineers. We are discussing common trade-offs in system design, and in this video let's look at the next one, which is performance versus cost. So in the previous video we saw a discussion about what is a ProACT framework, how we can actually use it to make a decision, to do trade-off analysis and so on. In this video let's try to apply that framework for performance versus cost trade-off. I hope you're ready. Let's get started. So in this video I'm going to tell you a couple of stories. In one story, performance will be the king, performance will take higher precedence, higher priority, and in another story, cost will actually have a bigger impact than performance. So let's see both the stories in this video. So here is the first story. We are at a company called Awesome Rides. So this is a ride booking company similar to Uber, Ola, right? And in this app, especially at peak hours, there seems to be some problem, right? So let's say we are at some busy junction where a lot of corporate buildings are there. Everybody is coming out to go to their homes. Maybe it's some kind of festive season, or maybe it's just regular peak hours during the day. The time is 6 p.m. and people just want to hire rides to go home, right? And let's say the number of cabs and bikes that are available are there in numbers, but they're not being able to match riders to cabs as quickly as they would hope, right? So that is the problem there. So because of this, the users are getting frustrated, there are a lot of delays, people are unhappy with their ride app, and they're just dropping, right? So there are a couple of complaints. App is slow, users are leaving, and the CTO or whoever is the system designer is actually worried about all this, right? So having observed all this for a few days, the system designer thinks it's time for a ProACT session, right? And in this ProACT session, the problem is defined, the objectives are defined, and finally we'll come at a solution to remedy this situation. Okay, let's see how that goes like. So the problem is ride matching is struggling during peak hours. So this is the important thing here. During peak hours it's struggling, otherwise it is okay. And when it goes beyond 100,000 requests, we are seeing approximately 5 seconds latency, right? So there is an increase in latency, because of which users are actually canceling the rides, and it is affecting the business bottom line, right? So this is the problem statement. And what are the objectives? Let's see the objectives. So even at peak load, response time should be less than 1 second. So that would be the ideal situation for any system designer. System is performing at peak performance even at peak loads, right? And then system should always be available, which will translate to increased trust with users, so that whenever they open the app is already available, up and running without any crashes. So high availability is definitely needed here. So that is one of the objectives. And global reach is one of the objectives that system designer is going for, right? So they want to expand this app to have a global reach. And finally, they also want to optimize cost, right? As always, there will be some cost optimization required whenever there is a system design involved, right? So let's say these are my 4 objectives for this ProACT session. And let's see the alternatives now. In order to achieve these objectives, the team or the system designer has identified 3 alternatives. First one is multi-region deployment plus auto scaling, right? So we are looking at a global reach, and we are looking at high availability. We are looking at peak traffic, which is happening during peak hours, and then it settles down. So we are looking at some kind of an auto scaling situation, which spins up more servers whenever there is a need, and spins down some servers when there is less load on the network, right? So we're looking at multi-region deployment plus auto scaling as the first alternative. And the second alternative is add a caching layer. Use some kind of a combination of Redis plus CDN. Put the static assets in the CDN. Use Redis for information that is accessed frequently but not updated as frequently. So put those stuff into Redis so that our latency comes down, our performance is improved, right? And the third alternative is rewrite code in Golang for concurrency, right? So let's say we have identified a new technology that can give us better performance when it comes to concurrent requests. So we are looking at 100K requests here, right? So maybe it makes sense to rewrite some of the code that is actually front facing to the customer, and it can handle concurrency really well. So these are my 3 alternatives, right? So let's see the consequences for each of the alternatives. So here I've written as A1, A2, A3. A1 points to multi-region deployment, A2 is caching layer, A3 is rewriting code in Golang, right? So our objectives are translated into columns here. So if you look at these objectives, they are roughly translated into these categories. We need high performance, we need high availability, we need global coverage, and we also want to do cost efficiency, right? So for each alternative, we're going to look at the consequences. So first one is A1, which is multi-region deployment. So for this, performance is high. We're going to do multi-region deployment plus auto scaling. We're going to spin up more servers, performance will be available. And it is also high in availability because of the same reasons. And the global coverage is high because multi-region deployment. And cost efficiency is low because whenever we are spinning up more servers, we are incurring more cost, right? So cost efficiency is low in this case. When it comes to A2, adding a caching layer, we are getting good performance because of the Redis layer and also the CDN. We are getting availability, which is medium because we have not really added more servers. We have just improved the performance of the existing situation, right? This is catering more towards latency. Global coverage is high if you are implementing CDN at a global level. So there are edge computing machines kept everywhere around the globe, and the users get nearest static assets from their location, right? And cost efficiency is medium. We have actually increased the cost a little bit by introducing a new caching layer, but in return we are getting good performance, right? Now let's look at the third alternative. Third alternative is rewriting code in Golang. So this will give us good high performance because Golang handles concurrency really well, and availability is medium. It is at the same level as before. We have not added any new servers. Global coverage is medium. It is at the same level as before. And cost efficiency is low because we have to rewrite the whole code, which means we have to put in development teams, maybe hire new teams who are specialists in Golang. And this comes with long-term benefits. Once the code is written really well, then we can reap long-term benefits out of it. But for now, it will incur some cost to translate one code base to another, right? So these are my alternatives, these are my consequences. Let's see the trade-offs now. So for A1, which is multi-region deployment, these are the trade-offs. We are getting performance and scalability, but at a very expensive cost. And for A2, we are getting performance improvement, but adding to cost. And for A3, we are getting long-term benefits, but it needs time and also development cost is incurred, right? So these are my trade-offs. So at this point of time, we need to make a decision now. I'll give you a few seconds to think about it. What would the system designer do in this case, considering the original problem statement and the objectives? Just think about it for a second. I'll show you what might be a good solution in this case. All right, so the decision is we're going to give higher priority towards performance and availability and lower priority towards cost, because at the end of the day, during peak hours, this is where we're getting most of the business. And if during this peak hour, if we are not able to cater to our users' needs, there won't be any business to run. So the cost is necessary for handling the peak traffic hours. So cost becomes a lower priority here because that becomes a necessity for running the business. So in this case, we're going to do a combination of A1 and A2, which means we're going to do multi-region support and also add a caching layer. So these are the couple of things that we're going to introduce. It's going to incur some cost to us, but it's going to give us higher availability, low latency, and multi-region deployment, right? Global reach as well. Okay, so this is how we're going to implement this. Now let's look at another story where the situation is entirely different. Now let's say we are at a different company now. It's called Awesome Basket, and it's going to deliver quick groceries, right? Similar to quick commerce apps that we have these days, right? So this is me. I'm sitting at my home. I'm launching the app. I'm ordering some products, and some guy comes and delivers to me in just 10 minutes or 15 minutes or whatever. So really quick delivery of groceries, right? And I'm happy because it saves me a trip. I can quickly do whatever I need to do with those groceries, right? So this is how the quick commerce industry works in general, right? The users are happy. The delivery executive is really happy because one of them is getting a job, getting a paycheck, and the other guy is happy because it actually solves some problem for them of going actually to a physical store and getting some stuff from the store, and in return they're going to charge a little extra for the delivery, right? So this is the situation on the consumer side. But The situation is different when it comes to the boardroom. If we have a quick look at the boardroom of this company called Awesome Basket, the situation is quite different. So let's say this is the boardroom. There are a bunch of executives discussing, and there is one guy presenting. Maybe this is the accounts department guy, and he's presenting the current balance sheet of the company. So he's saying revenues are okay, our users are happy, we're getting good revenue, which is fine. Our profits are for now okay, but there is a red flag here, which are infra costs, right? So our app is performing really well, our users are extremely happy, we're getting more users, we're getting more revenue, which is good, but our infra costs are actually very high, and if I do a projection, the infra costs might actually exceed the profits that we are projecting, and we might actually nullify the profits and get into loss situation, right? So this is the projection given by the accounts department, and now our CTO is sitting here. He's being given instruction by the CEO, mitigate this now, right? So we are at a situation where our infra is extremely performant, but our costs are also extremely performant, right? So the CTO is thinking, let's time to ProACT now. So let's see how we can remedy this. First, we will identify the problem statement. So company is facing rising infra costs, right? Which is a problem. Revenue is stable, but costs are overtaking profits. Financial stability is in threat, right? So when financial stability is in threat, it's not good for any business, right? So this is a problem statement we are dealing with. Now let's look at the objectives. The CTO has defined 3 objectives. Cut infra costs by 50%. Good, very neatly identified. Maintain uptime. We don't want to reduce the downtime. We still want to maintain the uptime decently so that our users are not affected. User experience should be ideal, right? So the entire shopping experience should not be affected as much because we are going to now reduce the infra cost. So the user experience should be ideal. So these are the objectives of the system designer. Now let's see the alternatives to handle this situation. A1, switch to cheaper cloud provider. Maybe use some regional cloud provider, nearby cloud provider who is offering cheaper rates for compute and storage. Switch to that cloud provider. And the second option is batch process instead of real-time processing. So there are some things during the order lifecycle that require real-time processing. Maybe order tracking status, maybe to track the status of the delivery executive along the way, and things like that. So these incur high costs. So instead of doing that, batch process them. So maybe periodically update their status and so on. And if there are any dashboards that need real-time updates, maybe use batch processing and give periodical updates instead of that. So that is some optimization we can do, which can reduce some costs. And the third option is use elasticity well. Use on-demand servers only during spikes, right? So this is a improvement that we can definitely do. So instead of taking very high performance servers and paying the bills month after month, we can take low performance servers and just take new on-demand servers only during spikes. So if we plan it really well, we can configure it to spin up new servers at a particular time, schedule time, or give some threshold beyond which new servers will be spinned up and spinned down automatically, right? So on-demand servers is something we can do. Data tiering between cold and hot storage is another optimization we can do. So some data points we will need immediately, maybe my current order, maybe just a few previous orders, but I would definitely not see as a customer what was my order last year, what did I order last year in May 2024 or 23, right? So for these type of things, we can use cold storage, right? Just put them in cold storage, it will be accessed with slight delay, and maybe that is okay with the users, right? And for hot storage, we'll use the latest information, maybe the recent 1 month or 6 months, something like that, right? So these are some optimizations we can do. Now we have to evaluate the consequences for each of these alternatives, right? Let's see how that goes like. So our objectives are translated into these columns. Cost reduction is our highest priority right now, probably. Uptime definitely is another objective. We don't want our users to face downtime. Latency should be decent. We don't want users to be dropping, right? So for A1, these are the consequences. So for A1 is switching to a cheaper cloud provider. Cost reduction is high because we have saved enormous costs by switching to a cheaper cloud provider. Uptime is medium. Maybe this cloud provider is not as highly available as the previous one. Latency is medium. It is the same as before, let's say, right? And for A2, which is batch processing instead of real-time processing, cost reduction is medium. We are saving costs from real-time streaming to batch processing. There is some reduction there. Uptime is medium. It is the same as before. Nothing is changing. And the latency is a little higher because we are now giving batch processed information. So there is some stale data involved here, right? And for A3, we have elasticity, which means cost reduction is high because we have spinned down the configuration of our existing servers. We are only going to spin up servers as needed. So this is our cost reduction. And uptime is high because we're going to have on-demand servers readily available when there is a peak requirement, right? And latency is also low, which means that because of these on-demand servers, our users will not face any higher latency. There will always be some server ready to serve their requests, right? And for A4, cost reduction is medium. We're going to shift part of the storage needs from hot to cold. So we have some cost reduction there. So cold storages are relevantly cheaper when compared to hot storages. And uptime is high, which is the same as before. And latency is also high now because in some situations, we might need to hit the cold storage to get some information. So the latency is a little bit high here, right? Now let's see the trade-offs. So for A1, which is using a cheaper cloud provider, we have high savings. Latency is increased, which is the sacrifice we're making. Uptime is reduced, which is another sacrifice we are making. But it gives us really good cost savings, which is one of the higher priorities that we had during the problem statement discussion, right? And for A2, we have good savings and manageable delays. So A2 is using batch processing instead of real-time processing. So we get good savings here with some manageable delays. I think users will be okay having a little delay in terms of status updates and dashboard updates, right? And third one is A3. A3 is using elasticity on-demand servers. Good savings, uptime is increased, latency is reduced. I think it is a good alternative because we are getting cost reduction without compromising on uptime and latency, right? I think this is something we should definitely do. And A4 is savings on storage, and the trade-off is increased latency on old data, right? So these are my trade-offs. Now we have everything in front of us. Now it's time to make a decision. So I'll give you a pause to think about among these alternatives, what is the one that you're going to pick? Just think about it. Okay. So I hope you got some answers. Let's see what this system designer has done. So as we have been discussing, higher priority here is actually cost and not performance. Ideal uptime and user experience, but not the best and super fast performance that we had earlier, which was increasing our costs through the roof, right? So keeping all this in mind, the system designer has decided to a combination of A2 and A3 and A4 and not do A1. So if we're doing A1, we're actually getting high savings, but latency is increased, uptime is reduced, which can be a problem, right? Users can be frustrated with increased latency and availability is compromised. So app may be crashing, app may be saying server not found and so on. So that is not a good situation to be in. But the rest of them are really good optimizations that we can actually do, right? If we do a combination of all these three, use batch processing, right? It's an improvement over real-time processing, and real-time processing is not really needed in every situation. It's good to have. Users will be really happy if you provide real-time processing, but I think batch processing is an acceptable solution in this case, right? And use elasticity, definitely we're going to do that. And data tiering is an optimization that we can definitely think about. It can save us a lot of cost, especially because the kind of business it is in, only the recent information is quite frequently accessed in majority of the cases anyway, right? So the decision makes sense, and this is something we can present to our stakeholders and get a buy-in, right? So this is how ProACT framework is useful for doing performance versus cost evaluation, guys. I hope you found this video helpful. In the next video, we'll look at another trade-off. Please leave a like if you found this helpful. Please subscribe if you haven't done already. If you have any questions, definitely let me know in the comments. Thank you so much for watching. I'll see you in the next one. Cheers.